Assalamualaikum. Hi guys. We are going to focus with the last subtopic of chapter 4, 4.5, metallic bond, where in this chapter you are needed to explain the formation of metallic bond by using electron C model. The next one, you have to relate the metallic bond to the properties of metal, where there are 4 of them. And the next one, we are going to explain the electrical conductivity of metal by using band theory, and also the factors that affect the strength of metallic bond. Metallic bond can be defined as electrostatic force between the positively charged metal ions and the sea of delocalized electrons. So, apa maksud delocalized electrons? Maksudnya, elektron itu boleh bergerak ataupun boleh move from one place to another place. For example, you see here, this is an example of electron C model for group 13. I choose aluminium. Aluminium is one of the metals in the periodic table, which is situated in group 13. So, it has 3 valence electrons. So in order for it to achieve the stability, it will donate 3 electrons and forming Al3 plus ions. So these all are the positive ions, Al3 plus. And you can see that in the electron C model, you got another electrons around Al3 plus ion. That's what we call as delocalized valence electrons. You should know that in metallic bond, we are going to discuss about metal atoms. So, metal atoms can be imagined as an array of positive ions immersed in a sea of delocalized valence electrons, such as this diagram. You can see that the negative delocalized electrons and positive ions from the metal. So these delocalized electrons are not bound to individual atom because they can serve to bind large numbers of metal atoms together. Maknanya dia akan mengikat metal atoms dalam kuantiti yang besar supaya metal ions ni tidak akan keluar daripada barisan dia. So we know there are several physical properties of metals. First is lustrous. Next can be hammered into thin sheets. The next one can be drawn into a wire. And also, metals are good conductors of heat and electricity. We are going to discuss one by one. For malleability and ductility, in metallic bonding, the electrons do not belong to any particular metal atom. So maknanya dia memang move around, delocalized electron. But if you have a sufficient force or enough force when applied to the metal, one layer of atom can slide over one another without disrupting the metallic bonding. This means that metallic bond is flexible and strong. Therefore, you can hammer metals into sheets. Sebab tu dia panggil istilah malleable ataupun drawn into wires. Istilah dia ductile without breaking the metallic bonding in the metals. Next one, we go for thermal and electrical conductivity. As I mentioned before, you've known about the term delocalized electrons in metals, where they are mobile and free to move away from negative electrode to positive electrode. Apabila metal itu ada connection with electrical potential. Di sini kita boleh faham metal tu ada higher electrical conductivity. Therefore, mobile electron ni boleh conduct heat. Dengan cara dia akan carry kinetic energy from hot part of the metal lattice to a cool one. High thermal conductivity. Istilah yang lebih senang untuk kita faham. So sebab itulah electrical potential boleh transfer along the metal lattice. Now kita fokus tentang band theory. So band theory adalah satu teori yang kita gunakan for solid, di mana electrons jump from valence band to conduction band even at ordinary temperature, dan ini berlaku apabila solid tersebut conducts electricity. So macam mana dia boleh terhasil? Conductivity bergantung kepada gap between valence band and conduction band. Kita akan gunakan dua term ini, valence band, conduction band. So if the gap or energy difference between these two bands is big, therefore dia akan behave as an insulator. Maknanya dia tak boleh conduct electricity. Sekiranya gap itu kecil, maknanya electricity boleh lalu between the valence band and conduction band. So mari kita lihat this illustration. You can see that we have example sodium. So sodium you have from 1s2 to s2 to p6 3s1. So that is for sodium. So apa itu maksud valence band? Valence band adalah di mana valence shell orbitals which have electrons in them. For example, kalau sodium, kita ada highest n value n equals to 3. So that is why valence band is made up of 3s1 orbital untuk sodium, because sodium ada this electronic configuration 1s2 to s2 to p6 3s1. So ini yang paling tinggi. Next, for conduction band it is made up of those orbitals yang tidak occupied by electrons ataupun either in valence shell ataupun higher unoccupied shell. That's why orbitals of conduction band are empty. So let's take a look again. Sekiranya awak ada 3s1 is the highest for Na, maknanya kalau saya ada n equals to 3, saya ada 3p next to 3s. So 3p itu akan jadi empty. So it forms a conduction band between 3s orbital. So itu maksud conduction band. So dalam kes ini, kita faham term tentang conductors. Sekiranya awak ada metals usually are conductors. So maknanya there is no band gap between valence band and conduction band. Dia akan rapat. So ini adalah contoh untuk metals, di mana both valence band and conduction band dia overlap with one another. So akan ada continuous availability untuk electrons lalu dalam bahagian this closely spaced orbital. Sekiranya awak ada semiconductors, energy gap dia akan ada sedikit size yang berjauhan antara satu sama lain between conduction band and valence band. Tetapi kalaulah awak ada elemen which is insulator, maknanya energy gap between conduction band and valence band akan makin besar. So dia ada large energy gap. So itulah cara untuk kita faham how the elements you got, whether they are conductors or not. So once we've learned about band theory, you are needed to explain how, for example, magnesium conduct electricity. So macam ni adalah cara di mana Miss akan ajar awak untuk determine the correct answer for this example, how you want to explain the correct one. So, first thing first, you have to write the electronic configuration for magnesium dahulu. So, we have this one. And seterusnya, kita kena tulis sedikit macam mana band theory berlaku. So, kita akan tulis, according to band theory, kita ada conductor, which is a material that has its valence band and conduction band overlap with one another. So, bila dia overlap, electrons akan flow through the material with minimal applied voltage. So ini first point awak. Kita faham apabila conductivity berlaku, both valence band and conduction band kena overlap, bertindih antara satu sama lain, so that electron boleh lalu. Next one, kita akan bagi tahu valence band untuk magnesium adalah 3s1 orbital. Kena bawa sekali elektron tersebut. And then after orbital 3s, next to it adalah 3p. Kita ada dekat sini, tapi 3p ni empty. That is why kita tak akan tulis number of electron. But we should know that this orbital 3p is empty, hence it forms a conduction band. Seterusnya, kita faham 3p dan 3s dia sangat rapat dalam term of energy difference sebab dia berada dalam energy level yang sama, iaitu n equals to 3. That is why dalam proses conductivity ini, electrons dalam 3s orbital akan dapat green light untuk jump ke arah conduction band 3p orbital. This is where ada flow of electron resulting the electrical conductivity. So syarat yang paling penting awak kena bagi tahu dulu valence band dengan conduction band overlap, and then sebab tu electrons boleh lalu, tentukan apakah valence band untuk elemen tersebut dan conduction band untuk elemen tersebut. And then next one, explain lah elektron daripada valence band akan jump to the conduction band, hence resulting the electrical conductivity. So itu point yang awak kena letak dalam awak punya answer. Seterusnya kita akan fokus bahagian yang terakhir untuk video ini, where the factors affecting strength of metallic bonds. There are 2 points here. The first one, number of valence electrons, and the second one adalah atomic radius. So that's why we can illustrate here strength of metallic bond is directly proportional to the number of valence electron per atom over atomic radius. So apa maksud dia? Sekiranya saya ada valence electron yang sangat banyak untuk spesifik atom, maknanya atomic radius dia akan berkurang. Okay? Ingat lagi awak ada pizzas, and after that strength of metallic bond akan bertambah. So itu adalah relationship between these 3 characteristic. So inilah yang kita maksudkan daripada case di mana awak nak lihat relationship between stronger metallic bonding due to the smaller atomic radius from the higher number of valence electrons. Awak boleh nampak dekat sini, from sodium until boron, the number of their valence electrons makin bertambah, dan you can see that sodium, magnesium and aluminium adalah period 3, while lithium, beryllium and boron adalah daripada period 2. Apa yang kita boleh conclude dekat sini, we will discuss 2 different periods about their melting point and boiling point. You can see that melting point and boiling point increase from sodium to aluminium due to increasing strength of metallic bond. So maknanya metallic character untuk aluminium adalah yang paling tinggi dan sodium adalah yang paling rendah untuk same period. Dan kes yang sama untuk period 2 juga. Daripada lithium yang paling rendah dan boron adalah yang paling tinggi. Dalam kes ini, we can see that aluminium has highest number of valence electrons. That's why strongest metallic bond, which resulting more heat is needed to overcome the strong bond here. Therefore, highest melting point dan boiling point. In this case, awak boleh nampak juga elements in period 2 have higher melting point and boiling point berbanding period 3. This is because period 2 have smaller atomic radius berbanding period 3. Kalau masih ingat, kita ada NSAS. NSAS, segitiga kita turun ke bawah menegak, so awak boleh nampak saiz dia makin besar. So awak boleh nampak period 2 has smaller atomic radius, that's why dia akan ada stronger metallic bonding. Then, more heat to overcome the strong metallic bonding. Kita discuss tentang metallic bonding ya sekarang. So, when going down the group, size increases, metallic bond becomes weaker. That's why melting point untuk Na is lower than Li. Because Na dalam period 3, Li dalam period 2. So that's all for metallic bond. I hope you can understand the important facts about metallic bond. Thanks for watching. Bye.